That is what he says, 2 times capable. Right? Doubly capable. Right? If the Cp value is less than 1.67, what does this mean? What does this mean? You are not doubly capable. You are like an elephant. Your variation is more. Yes or no?
Yeah.
So you should reduce the variation. Keep this Bible. This is a Bible statement. You should never forget, no? Understand? Cp should be 1.67. If Cp is less than 1.67, what does it indicate? Process is not capable. Why it is not capable? Because variation is more.
More.
Yeah?
Yes.
There is no other statement other than this. There is no other rules, right? If Cp is less than 1.67, if it is more than 1.67, it is very good. For certain industries, it should be as high as 6, right? We are not bothered. We are bothered that at least it is doubly capable. So 1.67 is important. Cp should be what value?
1.67.
Yeah, more than or equal to 1.67.
1.67.
Right? That will give you my impression that you have understood much better than what I have taught you. Right?
Yes, sir.
What I have taught you is 1.67. I have also taught you if it is less than 1.67, what is the problem? So you should create yourself understand, no? Understand? Because if you have said that, I would have appreciated Haritha is brilliant. Right? Now you have understood what I taught. Right? You should understand more than what I taught by inference. Right? That is what we stand for. That is what I want you to come at the end of the course. Right? Clear? Okay, yes, sir. Yes, not. This is the better. So Cp value should be 1.67 or less than that. Much better. I'm happy. And then if Cp is less than 1.67, there is a problem. Yes or no? It is not capable. And why is it not capable? Variation is more. Variation is more than the customer specification. Right? Or at least matching that. We are no safety factor. Understand? Huh? If Cp is 1, very bad. If Cp is less than 1, you will never accept. All the process items will be rejected. Now, what is CpK stands for? What should be the CpK condition? It should be equal to Cp. Yes or no? CpK should be equal to Cp. Right? Cp always will be greater than CpK. But if CpK becomes Cp, then you have perfectly achieved the target. Right? If Cp is not equal to CpK, only one condition. If Cp is not equal to CpK, then there is no capability. Why there is no capability? You are not targeting. Yes or no? It is not in the target. Therefore, Cp and CpK gives you 2 parameters. What are the 2 parameters? One is there a variation? Which factor gives you the variation is there or not? Cp or CpK? Which index gives you about the variation is okay or not okay? Is it Cp or CpK?
CP.
Cp. I want everybody to say Cp. Because only one person tells and everybody remains silent. What does it mean? Nobody has understood what I have said. Yes or no? Cp stands for only one thing. What is that?
1.67.
No.
Variation.
Cp does not stand for 1.67. Cp has to be 1.67. Cp stands for variation. If Cp is 1.67 or more, no variation. Right?
Yeah.
Okay. If Cp is less than 1.67, more variation. More variation. Right? Not allowable variation. It is not allowed. Variation. This variation is not allowed. Too much of variation is there, not allowed. Okay. So I will again repeat. Cp stands for variation and Cp is more than 1.67. Okay, variation. Variation is very good. If Cp is less than 1.67, variation is not okay. Right?
Sir, one question.
Yes.
Yeah, maybe it is very basic, but yeah, I feel of asking this. So, in whenever we want to find the process capability, we find the Cp, Cpk, we plot a graph and we see the variation, how it is. But how can we judge
Which graph do
uh,
you plot to find out CpCpk? No graph.
sorry, it is a calculation. Sorry,
Yes,
I
yes,
miscommunicated.
yeah,
We do the calculation and we arrive to an value and we say if it is okay, then
yeah,
the process is in control or then it is not in control.
yeah,
Now, when we draw the normal bell curve graph,
yeah.
okay, so how can we understand when to use what?
That comes by experience, right? That comes by
Okay,
experience,
okay,
right? I tell you,
okay,
when I ask you one graph you are using, use the graph again, normal distribution. See, this is the normal
okay,
distribution. Understood? Are you able to
okay.
see my screen? Are you
Yeah,
able to
yeah,
see
yeah.
me?
Yes, sir.
Right?
Yes, sir.
I'm
Yes, sir.
showing in my
Yes, sir.
hand. This is my normal
Yes, yes.
distribution.
This is
This
a
is my
bell.
process. Right?
Yeah,
Do you
yeah,
see a
yeah.
rectangle around me? Yes or
Yes,
no?
yes, yes, yes,
Right?
yes.
Now I am
Yeah.
capable. Right?
Hmm. Hmm.
Okay. Now I'm just going up, going up, going up. Where is my going?
It is
My
not capable. It is more or
that's
less
all.
flat.
This is what is
Yeah,
CpCpk.
yeah,
Right?
yeah.
It is the ratio of this distance between this distance. The ratio
Okay.
of this is the process control
Hmm.
limits, and this
Hmm.
is user specification limits.
Yeah.
If the process control limits are much lower, CP
Hmm.
value is very higher. Yes or
Hmm.
no?
Yes, yes,
Because
yes.
user specification limits is top,
Hmm. Hmm.
denominator is this. If this
Hmm.
is smaller and smaller, it goes to infinity. Process is very
Okay.
good. Yes or no?
Okay. Yeah,
I'm using
yeah,
the graph.
yeah.
I have shown you the graph. That's all. Right?
Right.
You don't know when to
And
use which graph and all. No, it all comes to you by experience. Right?
okay.
Simple
Okay.
thing. It
Okay.
is like
So
simple by calculations. I'm telling you, if CP
okay.
is less than 1.67, bad. If CP is more than 1.67, good. In what way? From the variation point of view.
Variation point of view. Yes.
And
Yes.
CP should be equal to CpK. You will be able
Okay.
to
Yeah.
appreciate much better if you know
Hmm.
how CpK is calculated after
Hmm. Hmm.
understanding what I say.
Hmm.
One
Hmm.
more time,
Hmm.
if you go through, everything will
Hmm.
be clear. Right?
Right.
Always no, they will say that no, revise. Why do they say revise? First thing you will understand.
Hmm.
Next thing, it will
Hmm.
just go in and then go into your brain. Right? Get
Hmm.
settled.
Hmm.
Right? This is what it is. Right?
Hmm.
Okay. Likewise.
And do we can we establish a relation in the bell curve with respect to CPK value? Means
With
if it is
respect to
1.6.
the user specification limits. Yes or
Okay,
no?
no. What I mean, yeah, that I understood.
Yeah.
But what I mean for calculating CPK, if I have certain set of data, can I use the same
No,
data for plotting the bell curve?
same data will do. The same
No,
data,
I can
you should know
you
that
plot the
where is the
yeah,
mean. You should know where is the mean, that's all. Process mean.
okay. So I
Right?
can plot the same data on bell curve as well.
Yes, I will tell you, I will show
Acha.
you. I will show
Okay,
you
okay.
probably if you can take the Gopal Kumar, Gopal Kumar, I should give within 20 to 9:20. Probably I will
Hmm.
share a screen now.
Hmm.
Uh,
Hmm.
I'll just show you.
Other than you were showing something on
One second, I'll
Thursday.
show you.
Yeah,
I'll show
yeah,
you.
yeah.
This CpCp. One second. What is this? Yeah. I'll have to see my this thing also. This also I will send you. I'll share you also if you require.
Right.
SDM,
Side or his side?
VBXL,
Yes, sir.
right? You will be able to understand much better, deeper, sir. This time, don't worry.
Anyway, I'm
Sigma
going to
level
speak
calculator.
about,
Sorry,
sir.
Sigma
I'm
level
going to
calculator.
speak about CpCpk as well as PpPpk after this particular
See
discussion.
here. Don't update. Right. Continue. Where is this?
Right.
RK sir, am I audible?
Yeah, you're audible.
Yes, sir. We can hear you.
Yeah, see here.
Yeah,
Are you able to see this?
Yes, sir. Yes, sir. I
Right?
can
You
see
see this
that. Yeah.
LSL and USL and Six Sigma.
Right.
All
Right.
the input required is LSL, USL, process
USL
mean and
process
standard
mean
deviation.
standard
This
deviation. Yeah.
LSL and USL, who is giving?
Specification limit is the
Customer.
Customer. Very good. All of you
Yeah.
have understood. This
Yeah.
process mean and standard deviation, who is giving?
We
So
are
that can be
calculating.
calculated.
No, we are not calculating. The process is giving.
Yeah.
Right? Process is
From
giving. Who is giving?
the
I'm
process
asking.
data.
Right? You can't calculate on your own. No, you process data will have to be there. Yes or no?
Yeah.
The
Okay.
process is giving. If you do the process, the output, this LSL and USL within this or not, you are finding out. You are finding out the average, you are finding out the standard deviation. You are only doing
But
the
standard
calculation.
deviation is calculated, no, sir?
Calculated from where?
From the process parameter.
From the process. So who is giving?
Yeah. Okay,
Not your
process is
employer,
defined by the
not your operator.
right.
Your process is giving. Keep this in mind. This is what is called YY analysis, and you will be able to appreciate much better.
Understood, sir.
This is like I'm a mediator, yeah. You are wanting something. And what you want is my wife is supplying. Understand? I will ask you what you want. I will check with my wife what she is having. If she is having what you want, then the process capability is there. What it is.
Yeah.
Yes or no?
Yes, sir. Yes, sir.
You want a
Noted, sir.
biryani with 2 mm salt. My wife is having a biryani with 5 mm salt. Is it okay? So it is not capable. This is what we are saying, right? What is that you want? And is this within the limit from my wife's supply?
Yeah.
Understood?
Understood, sir.
Clearly shown in the visible. And how CP is calculated is shown here. If this is moving this way or that way, it will be less than that. That is being shown here. Yes or no?
Okay. And this graph also changes when the value changes?
Yes.
Means
And
that is
CP,
also automatic?
CpK, DPMO, performance. This is called short-term performance. This is called a long-term performance level. But what we want to do is, we want to find out, considering the variations of all the factors, which is going to happen over a period of time, PpPpK. Right? That is called long-term capability indices. Yeah? Called
Understood.
long-term capability indices, that is called the PP and PPK. Over to Gopal Shukumar to explain you what is PPPPK. Thank you very much for
noted. So this Excel, when you have time, share, sir.
Yeah, definitely. It is already there. I'll share it also. No problem.
Yeah. Thank you, sir. Noted, sir.
Yes, sir.
All right,
Gopal
so-
Shukumar. Oh, 3 minutes
Yes,
more.
sir.
Sorry.
No,
3
no
more
problem, no
minutes.
problem. Sir, no issues. I'll start.
Yeah.
Okay, good morning, all of you. Hope
Good morning.
doing great.
Good morning, sir. Yes.
So the next level of learning is will be converting you to the next transformation, black belt. That means you will have a deeper understanding of all the tools you have learned already, and over and above, we'll be learning about certain new tools, right? So additional tools which only black belt will be using. So some of them are, one is PpPpK. You already started talking about it today. Process performance indices. Already we learned one thing, process capability indices. So sometimes we call them as short-term capability measures and long-term capability measures. So why do we call we'll be discussing today morning is design of experiments. Design of experiments. Am I audible properly to all of you?
Yes, sir.
Yeah.
Yes.
Correct.
Yes, yes.
Thank you. So design of experiments is nothing but an upgraded version of your hypothesis testing. We already studied hypothesis testing. What we studied in hypothesis testing, what is our understanding about hypothesis testing? Can
There
all
are
of you
two
tell me?
hypotheses. One is a null hypothesis and alternative hypothesis.
Correct, correct. And we try to study whether a factor is critical or not. We keep the factor on the right side of the equation, which is an X factor or X variable. And then we try to understand whether the X is influencing the Y. Am I right? At a particular period of time, at a particular instant of time, you are checking whether the X is influencing your Y. Right? So that's called hypothesis testing. That means you are studying the factors one by one. But how many factors can be influential? Is it always one or it can be many? It can
Multiple.
be many. Sometimes if the critical factors are multiple, you may have to study them together. Earlier in hypothesis testing, we studied them one by one. But in design of experiments, you will be studying all the critical factors simultaneously. That's how you are going to differ from the traditional research. The traditional research, traditional analysis is one factor at a time. But in design of experiments, we study factors simultaneously. So that we get some additional insight about the influence of the root causes. So these are the two areas we are going to touch upon today, and we will try to gain a clarity on that. So the first to discuss is PP and PPK. Of course, today afternoon onwards, again, you will be taken back to define phase, some interesting tools like QFD and usage of Minitab and all those things will be teaching you. Again, in the improve and control also, some additional tools so that you can arrive on a right consensus very effectively, right? So with that note, let us proceed to the slides. So do you want to ask any question about CpCpK before I talk about PpPpK? All right. Hope all of you had some practice with the sigma level calculator that has been given to you. Because
Yes.
practice always can make you perfect. So here is the summary. Here is the summary. Ultimately, we want our CpK to be more than 1.66. If CpK is more than 1.66, automatically your Cp is more than 1.66. Hope all of you know Cp and CpK are related. And at the maximum, what can happen is, the best that can happen is Cp will be equal to CpK. The best that can happen in your process is Cp will be equal to CpK. So always to understand about the capability, look at the CpK. If it is more than 1.67, all good. Your process is capable and your process is consistent. Another possibility is Cp can be more than 1.66. CpK can be worst. If CpK is worst, Cp is better. That means your process is consistent, but not capable. You should learn to use this word, right? If your Cp is healthy, what can you conclude? You can conclude your process is consistent. It can be consistently good, can be consistently bad also. But the primary requirement is fulfilled. Process is consistent. That means the SOP is really functioning. And now you improve the SOP, your process capability will improve. And that will make your CpK also healthier, right? So this is how you can interpret Cp and CpK. And this is the ideal scenario, the best scenario. Cp equal to CpK. If Cp is not equal to CpK, the remedy is we try to shift the process center towards the target value. And if Cp is lower, we try to reduce the variation. All right. When CpK is under trouble, one immediate suggestion is shift the process. When Cp is under trouble, the suggestion is reduce variation. Right. If both are under trouble, then you have to do both. Right. You have to do both. I mean, you have to shift the process as well as you have to reduce the variation. And for critical process, the requirement is 1.66. Then for non-critical process, the requirement is 1.33. Hope this is very, very clear to all of you. And better, you all can work on some data, some case study, and where you just have to know these things: USL, LSL, and then X bar and sigma. X bar and sigma are nothing but process average and the process standard deviation, right? So this, I think we have finished already, right? I have explained all of this and the thing is available. So this question also I already asked, you all answered nicely. I'm now moving on to the next tool, process performance indices. Let me ask you a question. Tell me, if I give you an option to choose between the two, one side is capability, other one is performance. What do you want? You want capability or you want performance? Because CpCpK are known as process capability indices. PpPpK are known as process performance indices. Tell me, if I ask you to choose any one out of the two, capability or the performance, which one will you choose? You want capability or you want performance?
Performance.
Performance, because ultimately the performance matters, isn't it? What are you capable of? You can be capable of many things, but what do you deliver?
Delivery.
So, yeah, what actually customer experience is, customer cannot experience your capability. Customer can only experience your performance.
Performance.
Like in the program also, we might know many things, but what do we deliver? That matters to you, isn't it? So similarly, you might be offering a product, offering a service. What is very important from the customer point of view? When I say customer point of view, long term, what is going to be your customer experience with your product? That means it is long term. That means, customer is experiencing your long term capability. Customer is experiencing your long term capability. And the long term capability, we call it as performance. Now, the equivalent word for long term capability is performance. You now remember all of it. Now you understand there are two things we are talking about. One is short term, the other one is long term. Sigma level short term, sigma level long term. Short term means capability. Long term means performance. Hereafter, if you want to know the capability, that means your thinking is short term. Hereafter, if you use the word performance, that means your thinking is long term. But irrespective of the amount of data you have in your hand, but by using an appropriate technique, you can always get an estimate of your capability. Always you can also get an estimate of performance. All of you get my point, because always in every batch, people ask me this question: sir, how do you differentiate? What we all can do? We all can do only the best that is possible. Am I right? We all can do only the best that is possible. If I have 1 week data, with 1 week data also, I can find out my capability. I can find out my performance. Please understand, statistics is only estimation. It's not accurate finding of anything. We are not finding out anything accurately, isn't it? But we always try to get an estimate what will happen, right? If everything goes well as per our judgment, what will happen? That is statistics. But even though we judge many things, sometimes, the opposite will also happen. That is called uncertainty. The certainty part, we call it confidence level. The uncertainty part, we call it variation, or, the error. All of you understand? So it is you who is going to differentiate the short term and long term. You don't have to ask the question again, sir, again and again. Sir, what is short term? What is long term? Best of my ability, this is short term. This is long term. Right now, all of you are learning the course. You are in the touch of the subject, isn't it? So how many months you will have a good memory of all these learnings? At least for 1 month? At least for 1 month, right? So you are saying me that indirectly you are saying me that the tenure is, if the tenure is less than 1 month, then it is short term. Anything more than 1 month, that becomes a long term. Because the tendency, if I conduct the exam after a month or after 3 months, then the performance will be different from the capability. Now all of you are acquiring the capability. So at the time of short term, the advantage is your capability and performance will be more or less same. Isn't it?
Yes.
So whenever you have you want to understand the short-term capability, then you can actually calculate. Both will be more or less same. However, in a long term, and your long-term capability will definitely be different from the short-term capability, and that's why we have another terminology called performance, right? So here in my slide, I'm showing 2 cricket players. You could see them. One is who is he? Shikhar Dhawan. Other one is Sourav Ganguly. So tell me, if you have to choose between the two so that he can play for your team, whom you will choose?
PpPpk. Dhawan.
Yeah, because you all know, so even though Ganguly is a very good player, but his fitness
Perform-
and his performance in the current match is doubtful. Though he is capable, he cannot be a performer.
Yeah.
But Dhawan is currently playing, so he is not only capable, he is also a performer. So in our business also, what do we need? We just need capability, or we need both capability and performance?
Both.
So hereafter, please always look at both measures. Measure the capability also, measure the performance also. Be happy about what you have in your business, right? If it is, if the values are healthier, yes, then you understand you are going to be successful even in the long term. If suppose only the short-term measures are healthier, it indicates that everything is going well as of now, but probably in the near future, things can become worse, isn't it? So you become proactive with the help of all these tools. All right, now coming to the rules, guidelines, as per the AAG, Automotive Industry Action Group, the PpPpK recommendation is again same recommendation. For the PpPpK should be 1.66 for critical process, and for 1.33 for less critical process or non-critical process. So what is critical and what is not critical? Who has to define? You have to define. If your customer takes if your customer become offensive for even a single small deviation, then that's a critical process for you, isn't it? So understand your product, understand your customer, and if the customer is going to be very, very sensitive with respect to a particular failure, then the process you are dealing is critical. Otherwise, less critical. Suppose if there is a defect and customer just ignore it, that means your process is less critical, isn't it? A small scratch on your mobile phone screen, I don't think any customer will tolerate. Am I right? Small scratch on your mobile device screen is critical. But the same scratch on the carton in which the mobile is packed, that is not critical. Am I right?
Accept.
So that's how you need to understand your product, your customer, and even his approach towards any deviation or a defect. If he finds it critical, then for you also it is critical. Then you must aim for a CpK value of 1.66. If it is less critical, then you should aim for a CpK value of 1.33. All of you understand what is critical and what is less critical?
Yes.
Yes.
So here is the formula. Formula wise, there is no difference. You can see PP equal to USL minus LSL by 6 sigma. Similarly, PpK the same like your CpCpk. Minimum of PP upper, PP lower. Sometimes here, instead of calling it as PP upper, PP lower, they call it Z upper and Z lower. These are all terminologies, right? But ultimately, yeah, all are same. So capability depends on the process variation and the position of the process center. Hope all of you know what I am talking about. Process center, you all know the central tendency of your process. Sometimes your sample average can indicate the process center. Sometimes average of the sample averages can better indicate the process center. Am I right? Sample average indicates our process center. Why do I say process average? Because I only have a sample. I only have some samples. So I calculate sample average and I will use that as the indicator of process center. If I have multiple samples taken at different points of time, right? Multiple samples taken at different points of time. And at each point of time, if I have, some, again, multiple samples inside each group, what we call it as subgroup, isn't it?
Subgroup.
Then every subgroup will have an average. Then average of the averages, that will be a good indicator of my process center. Hope all of you agree with me.
Yes.
So finally, it depends on how you collect the data, how you use the data. Accordingly, your estimation, can become more and more accurate. Right? Your estimation can become more and more accurate. So capability depends on two things. Both are statistics. One is variation. The other one is center. Center means central tendency. It is average. Most of the time it is average. And again, the capability can be of two types. One is short-term capability. The other one is long-term capability. Just now we spoke about short-term and long-term. There is no strict rule. This period is short-term and this period is long-term. No. You have to better understand, isn't it? Always, the scenario has to be understood better, and you can define and differentiate. Or if your customer says no further question, if your customer says this is short, hope all of you agree with me, because that's his requirement. So when a definition is available, please follow it. If that is not available, you have to create it logically. All right.
Okay.
So there is short-term capability on the left side, long-term capability on the right side, and long-term capability, you only have the other one is PPK. Well, that is also known as overall capability. Already we have studied CpCpK. Please note, we have taught you CpCpK without even letting you know that there are three types of CP and CPK. How many types of CpCpK? Three types of CpCpK. And one is
CP greater than 1.66. Sir, voice
Your
not clear.
voice is breaking.
Sir, voice is
So your voice is
voice
not
is
clear,
not-
sir.
There is some lag.
We can't hear you, sir.
Gopal Shivakumar, you are not audible.
The one is called between. Ask you, my voice is not audible. How is it now?
Sir,
Better?
we can't hear
No,
you.
sir.
Yeah.
How long?
Echo.
Yeah,
Oh,
but
1 minute,
last,
I guess.
From the
last
three
30
types of
seconds.
CpCpK.
Yeah.
Oh, three
Last
types of
30 seconds, if
CPCPK.
you
Yeah,
can
three
repeat.
types of CpCpK.
I'll repeat. I will repeat. Now it is better.
Yeah, far
No,
better.
echo.
Again.
Echo.
So again,
Is
echo is there. Sir.
No,
Echo,
sir, not
echo
better.
is there, sir. Not better, sir. No, sir, not better.
No, we lost you, sir.
Is it better or not?
No, sir.
No,
No,
no.
No.
no, sir.
How is it now?
No,
Is it
sir.
better?
Yeah. Yes.
Okay. How is it
Yeah.
now? How is it now? Better?
Yes. Now we can hear
Can
you.
you hear me now?
Yes, yes.
Slightly,
Yes, sir.
slightly better.
Slightly echo is there.
Yes. Yes.
Are you able to hear me?
Now it is again gone, sir.
Right, sir.
Breaking,
your
sir.
voice is
Frequently
breaking.
Oh, maybe some connection instability. But is it getting better or not?
Now, okay. sir.
Okay.
No,
but,
okay,
sir. Okay,
Getting
right.
better,
No.
but we are not able to see your lip movement.
Now
No,
close
you
to
are
okay.
not able.
Yeah, we are not able to see your lip movement, but we can hear you.
That's
PPK
okay.
is not okay, sir.
PP.
That's not
Variation is there. Target is not there.
Yeah.
Variation is okay. Target is.
All right. All right. All right. All right.
Yeah. now
Okay,
we can-
because I am in another place and that's why. Okay, I think I should be audible now. I am keeping my voice a little louder.
yes.
Yeah.
So there are three types of capability I'm talking about with respect to CpCpK.
Sir, again we lost
There
you, sir.
is within capability, there is between capability, and there is combined capability.
Sir, voice is not clear.
Really.
So maybe network not stable.
Let me, yeah. I'm not speaking right now. That's right. So let me, if you want, I will check with other network.
No, so better.
RK sir,
video-
என்ன வீக்கா இருக்கா என்னோட வாய்ஸ்
ரொம்ப வீக்கா இருக்கு. அது ரொம்ப வீக்கா இருக்கு. That was very
No.
weak.
Okay. So we are talking about capability. Hope so far is good. All right. So we are talking about CpCpK, three types, and out of which non-industries they use the within capability. That is the reason why they don't. There is a reason why they don't use this sigma between and sigma combined. But slowly you need to differentiate all of this. Okay. So the main thing is within. Similarly, this side is over. First of all, let us try to understand the how we can differentiate the overall capability and within capability, and then you can come to the remaining. All right. Now again, another when to go for a capability study. You all can go for a capability study only when the process is under statistical control. Only when the process is under statistical. How do you know the process is under statistical control? Any answer for this? Will you be able to understand whether your process is under statistical control or not?
Yeah.
Data. Can it answer? Try to answer
Yeah.
this. How do you
PPC.
know whether your process
With
is
CP,
under
with CP value, we can understand it is in control.
If it is a normal distribution.
Very good.
No.
If it is a normal distribution, somewhat closer. But CP value, see, CP value doesn't talk about whether the process is.
PP value is different. Hello.
We are not able to hear you.
Sir,
The sir is not on the call, I guess. Yeah, now we can see him.
Yeah, sorry, I got disconnected because of the network only. All right, see, you can check whether your process is under control or not by looking at your control chart. In your control chart, if points are falling outside the control limit, it means your process is out of control. Under such situation, it is not advisable to conduct capability analysis. Under such situation, it is not advisable to conduct capability analysis. But when the process is under statistical control, you can conduct capability analysis. Again, when you decide to conduct capability analysis, there are two things. One is short-term capability, other one is long-term capability. When to look at short-term capability, when to look at long-term capability, again, you have to define your requirement, right? All right. So if your process is out of control, you still conduct the capability analysis. It simply means, it is similar to a situation, situation of conducting examination to someone who has not even gone through the training and the course material properly. Imagine a situation where you have not attended any of the training session. You have not gone through the recording. You have not gone through the course material. You have not taken the mock exam. Are you in control? Tell me. Are you in control?
No.
You're out of control. You have been influenced by several external factors, isn't it? Sometimes you have a function at family, sometimes your office meeting, sometimes some health issue. That means you are out of control. So I am seeing that such out of control situations in the process data. Under such situation, it is not advisable to schedule your exam. Am I right?
Yes.
If I schedule your exam, either you pass or fail, it is not going to give the correct picture.
Yes, correct.
Same thing I'm suggesting. If your process is out of control, please don't conduct capability analysis. Your focus should be to bring the process under statistical control. Afterwards, once the statistical control is achieved, then you conduct capability analysis, look at the numbers, it will make sense. Because ultimately, why you need numbers? You want to understand. You want to get an estimate of how your process will deliver to products and services to your customer. So that's very important. So with that note, yeah, so let me share the screen and then take it. So I think now there is a proper clarity between short term and long term, as well as when to conduct capability analysis and when not to conduct capability analysis. Keep this example in the background and then take a decision. But finally, if in your company, tomorrow, if your boss wants the capability analysis report, you cannot say, I will not give, because that is impossible, isn't it? Because he wants it. He is your boss, and as well as, he becomes your, the customer. He wants it. So you have to do it. That's a different story, right? But the thing is, we should not. All right, now I have data. Let us calculate CpCpK as well as PpPpk. The same data is available in the Excel file I have shared with all of you, sigma level calculator. The file name is coating thickness. So imagine there is a manufacturing process where the coating thickness is a CTQ, critical to quality characteristics. The coating thickness must be, let's say, 50 microns. 50 microns. Plus or minus 3 tolerance given by the customer. So what is the upper spec given by the customer?
53 micron.
Very good. Lower spec, 47.
47.
It is a two-sided tolerance, two-sided process, two-tailed process, for which now you have to find out the capability. You want to know your capability. And now you have so much understanding about capability. What is your understanding? There is short-term capability. There is long-term. So which one to look at? Now tell me, which one will you look at now? Short-term capability or long-term capability?
Long term.
Long-term. Because always looking at long-term capability is a better idea, isn't it?
Yes.
But if your boss doesn't know that performance measure exists, he asks CpCpk, then what will you give him? You will give him the short-term measure.
Short term.
Because he is asking that, isn't it? But having a performance measure healthier is the better scenario, right? And now 1 week time is available to conduct your capability study. Now you are forced to complete your capability study or data collection procedure within that 1 week time. Am I right?
Yes.
Because you are asked to give the report by next Monday. You only have 1 week. All right. So having understood the situation, the maximum duration of your study will be 1 week data. Yes or no?
Yes.
And 1 week means 7 days. 7 days, every day, there are 3 shifts. You collect data from all the shift, and then all 7 days, whatever possible, you are doing it, isn't it? But if your boss doesn't, limit you with 1 week, then what can you do? You can conduct this, extend the study for 2 weeks also. If I collect the data for 2 weeks, will I get a better estimate?
Yeah.
Better
Definitely.
estimate I'll get, isn't it?
Because
Because
more
2 weeks,
sample.
2 weeks data, 2 weeks data
More
is
sample.
obviously better than 1 week data.
1 week data.
Suppose if I have data for 1 month, then it is much better.
Still better, yes.
More sample.
Ultimately, we need to understand the situation and the requirement clearly. Right? The more is better. The more the data, the better will be your statistics. If better will be your statistics, better will be your prediction. Right? So, but there will be no compromise we will be making. We can't go for 100% confidence. We all know, isn't it? So that's the thing. So now the thickness, coating thickness should be 50 micron plus or minus 3. And now the study is conducted for about, 25 times, sorry, 25 times. 25 times sample is taken. Can you see that? Roll number 1,
Yeah.
roll number 2, roll number 3, and then roll number 25. This 25 can be scheduled over a week or scheduled over a day or scheduled over a month. It depends. But here I have 25 slots of data. Why 25 slots of data? Because they manufacture the material product with the raw material comes in the form of rolls. Comes in the form of rolls. Once you load a roll, and the products will be produced. Thousands of pieces will be produced. And once the roll is exhausted, you go for changing another roll, right? Roll number 2. So now this is how the process is going on. Now 25 different rolls were loaded, and production is done, and samples are taken. And from every roll, 1 sample is taken. one sample, but that contains 3 units inside. That means the 3 together is subgroup number 1. 3 together is subgroup number 1. Likewise, 25 subgroups of samples are taken. Now, totally, you have 75 data points. All of you understand?
Yes, sir.
Why 25? If you ask me why 25, that is governed by the particular organization and the requirement and the situation there. Am I right?
Correct.
Yeah, because that is the possibility. So they did that. Similarly, you can do it according to your possibility. Now with the 75 data point, we are going to calculate.
So one question in this: if the data points are, let's say, only 10, can we conduct the analysis? Means, does it have a minimum requirement of data? What I mean to say.
Okay, if the data point is you only have 10, right? Yeah, you can still calculate, but then as
Accuracy
we
is
always say,
plus.
no, you should know your limitation. You should know your limitation. See, if that has to be calculated, you can calculate. You can calculate, but then
Okay.
you should know that your the limitation is insufficient data in hand. Right?
Okay.
That can sometimes, that means it can give a completely different picture of what can actually happen.
Noted.
So that's the point. Anyway, let us do this. I mean, do this for this particular thing, then you will be able to get a better clarity. All right. So that's but that's why the thumb rule says you should at least have a 30 sample size. That is a thumb rule only, right? Okay. So now with the 75 data. Now, let us see how the calculation works to get CpCpk as well as PpPpk. Number of subgroups 25. Then each subgroup 3 data point, and subgroup size. I mean, total number of samples is 75. Now, tell me, will you be able to calculate subgroup range? There are 25 subgroup, so you will be able to calculate 25 ranges. Am I correct?
Yes.
Yes, sir.
Yeah, because the range is very simple, maximum minus minimum for each subgroup. So 25 range you have. Why do I want you to calculate ranges? I want you to get an understanding of the variation within each subgroup. The variation within each subgroup. There are 25 subgroup, so there can be 25 variation, isn't it?
Yes.
They are represented as R1, R2, etc., R25. Now I want to convert them into a single measure. I want to convert them into a single measure. So that's why I'm going for R bar. What is R bar?
Average of all.
R1 plus
Average of all the 25 ranges. That is happening here. R1, R2, R3 up to R25 divided by 25. My R bar is now available.
Yes,
R bar
sir.
is now available. This is actually R bar, not R bar.
Drop series.
Yeah, R bar. Okay. Now, R bar is available, and standard deviation is a better estimate of variation than your range. So I am trying to convert the obtained R bar into standard deviation. The relationship is, this is empirical. Whenever I say empirical, this is based on the experimental finding, based on some past research. So R bar divided by D2. R bar divided by D2. R bar is obtained. D2 depends on your subgroup size. What is your subgroup size right now?
25.
3.
Subgroup size is not 25. Number of subgroup is 25.
3.
3, sir.
Subgroup size is 3. Sometimes
3.
it is written as sample size. 3. For sample size of 3, what is the D2 value?
1.693.
This table is available. So 1.693 is used, R bar is used to get the standard deviation version of the variation. Variation as a standard deviation is given here. And now this variation is within variation. This variation is within variation. Whatever the variation I am going to see in your exam mark, that is going to be variation within black belt batch 33. Am I right?
Yes.
Whatever variation I'm going to see in your marks, exam mark, that is going to be a variation within batch 33 of black belt. If I want to know the variation between batch 33 and batch 34 and batch 32 and so on, that is called between variation. Am I right?
Yes.
Yes.
The difference in the performance between batch 33 and other batches. That means I'm talking about between variation. If I want to know the between variation, I will use the average batch average for batch 33 and batch average for batch 32. Am I right?
Yes.
Yes.
My approach will change so that I can understand the within variation. I can also understand between variation. But coming to our scenario, manufacturing scenario, we collected data with respect to roles. With respect to roles. Roll number 1, roll number 2, up to roll number 25.
25.
When I say within variation here, what does it mean? Variation within the role.
Each row.
Variation within
Within the
variation
role.
in each role.
Yes,
When
correct.
sigma is small, it means all the units
Short term.
that are coming out from a particular role will have the same specification. Will have the same characteristics. If the variation within variation is minimal, what does it mean? All the units that are coming out from a particular role will have the similar characteristics. Am I correct or not?
Yes.
If the variation in your exam mark is going to be minimal, then as a company wants to hire you, they can randomly hire any one of you because all of you are now having the similar characteristics.
Similar characters.
If they have to hire based on the mark, they can hire any one of you randomly because all of you have scored, close to each other. Can you see that, all of you? If all of you
Yes.
can score close to each other, then I can randomly pick someone. So that is the meaning of having a lower within variation. Hope it is clear. If you use this standard deviation in your CpCpk formula, that is called short-term capability. That's all. All of you understand? Earlier, I have not asked you to calculate. I have given you the value. You remember, in all our exercises, we just gave you the standard deviation straight away, and you just used it. But now, having the data in hand, you want CpCpk. Then, what is the standard deviation you all must use? Within standard deviation.
Within standard deviation.
How to calculate within standard deviation? Subgroup range.
Subgroup range.
Average of the range.
And range.
Average of the range divided by D2. That is your within standard deviation. This procedure must be followed so that whatever capability measure you calculate, that can be called as short-term capability or CpCpk. Clear now?
Yes.
Yes.
Okay. For the same situation, I want to understand what will be my long-term capability. My process right now, look at my CpCpk. Look at my CpCpk. 2.46, 2.37. Am I capable now?
Yes.
Am I capable?
Yes.
I am capable.
Yes.
Am I meeting the standards? I'm meeting the
Okay.
standards. Because
Yes.
what is the standard? AIAG standard is 1.66.
6.
I am comfortably meeting the standard and everything is going well. I have a doubt. If I run the process in the same manner, will I remain capable after 6 months? Good question, right?
Yes.
If I run the process in the same manner, will my process remain capable even after 6 months? Because I have a boundary that after 6 months can be considered as a long-term capability. Now one person is coming, suddenly in between, and he says, "Hey, no, this process can't even perform in this manner after 3 months." Now he is telling me that, hey, 3 months is the boundary line. 3 months is the boundary line. So the capability after 3 months is now considered as long-term capability. So it is ultimately you yourself drawing the boundary line. Now I want to understand, is my process can remain capable even in a long term? To get an estimate, what you can do is with the same data, available data, how many data you have?
25, 25,
75.
75,
75.
75,
75 data
into
points.
3.
including
Yeah.
subgroup.
Use the best of the available, use the all available data, all 75 data. Try to make best use of all the data. All 75 data is used together to calculate a standard deviation. To calculate a standard deviation.
Deviation,
That is known as overall standard deviation.
standard deviation.
Can you type all 75 data in an Excel? And then can you calculate a standard deviation out of it? Possible, right?
Yes,
Yeah.
sir.
You know how to get standard deviation in Excel, stdev.s, and select all the
Yes.
data. And that is going to be 0.8384. Look at your within standard deviation, look at your overall standard deviation. Do you get any inference? What do you understand now? Within is
It is-
0.41, between
It is
is
almost half.
0.83. Almost doubled, isn't it?
Yes.
That means your process capability is going to be pulled down drastically in the long term. If you run the process the same manner, the process that is doing extremely well today will start producing lot of defective items.
Okay.
In the long run. You can see the variation almost doubling. It predicts, and when you get PpPpk formula wise, there is no difference. Formula wise, there is no difference.
Your voice is not audible.
It's not clear.
Calculate PpPpk, it is 1.19 and 1.15. Now I am asking you a question. Is your process capable in the long run or long
No.
term?
No,
Tell me,
No.
what will be your answer?
no,
No, sir.
If I ask you, is your process capable in short term?
Yes.
short
Yes.
term is
Yes.
Very good. So this is how discussion has to happen in your workplace also. If I don't know anything about CpCpk PpPpk, I will only ask, is your process capable? Now what will you say? You take
Okay.
advantage of the discussion and you will say it is capable. Because your CpCpk is 2.37, 2.46. In this situation, it is better to talk anything about PpPpk because the other person doesn't know anything, isn't it?
Yes.
Am I right?
Yes.
If the other person doesn't know anything, don't try to educate him. Rather, you take advantage of the scenario and then win the scenario in your favor. That's all. Am I correct?
Correct.
Yes. What is required, you use only that much. But if the other person is going deeper, you can also go deeper. Or if there is a requirement that you want to understand, deeper about what is happening in your process, then you use all these tools. Otherwise, not required. Just because you learned the tools, don't try to use all of them. Sometimes, it might backfire. All right. So now this is the Minitab report. We will also generate the report on our own. And all of you can parallelly open your sigma level calculator to get the data. And all of you can parallelly open your Minitab so that we can generate a similar report ourselves so that you will be, feel more confident. And see here, the curve, short term, look at the way your process is performing. It looks very narrow here. Same process with the same data. Look at the red color curve. It has become more wider now, isn't it?
Yes.
Yes.
Become more wider. So, but the center is not that much shifted. That is because of having PpPpk closer value. Can you see that? They are closer.
The
That
chart
means,
what you showed, sir.
Yeah.
Almost closer to 1.66.
yeah, close to each other. That's why there is no shift in the process. You can see that process, the center only. However, the spread has increased more, and so we will generate this report ourselves. Okay, so similar one only, because here it has some rejection detail. Look here, when I use the, what you call, when I
Between
use,
expected over.
yeah, overall, when I use observed means according to the current scenario, there are no rejection. PPM is 0. Can you see that?
Yeah.
Yes.
Right now, nothing is rejected. All the pieces I have produced out of the 25 roles, according to the study, nothing is rejected. PPM is 0. But considering long term, look at my PPM. How much is my PPM? 394. 394 units are expected to be rejected. 394 parts per million. If you run the process, produce million units, how many are expected to be rejected? 394.
392.
Yeah, whatever it is. Out of the rejection of 394, 292 will get rejected on the left side, because the process is slightly shifted to the left side.
Right.
What is the center here? 4753. Center is 50. But your process average is 49.8. Can you see a slight shift on the left side?
Yes.
That's why
yes.
rejection on the left side is higher and right side is lower. Hope all of you understand, how how rejections are happening in a long term, because we estimate that with the help of overall standard deviation. Why the rejections are nil in short term? Because that is estimated with the help of within standard. So now we have to do this ourselves, right? We have to do this ourselves. If your process is, I think already I have given the condition. If the process is statistically out of control, what is the suggestion? Will you conduct capability analysis? Will you conduct capability analysis?
No.
You have to make it controlled, statistically controlled.
Yeah. So this is the suggestion. If the process is not in statistical control, it is better avoid conducting the capability analysis. Your test can be postponed instead of conducting it. But if the participant want to take the exam, what will you do?
Conduct.
We conduct. It is his fate. He wants to take the exam, so exam will be conducted. Similarly, if the customer, your boss wants the capability study report, and your process is out of control, what do you have to do? You have to do it.
Conduct, yes.
But normally, how you do it? You collect data and then you plot it in the control chart. Then you see a lot of points going out, like in the graph. Let me show the graph. Like a lot of point going out. Yeah, like this. Points are going out. Can you see your points going outside the control limit?
Yes.
Yes. Red color.
So according to our understanding in the courts, we are not supposed to conduct capability analysis. But our boss wants the report right on the same day on his table. So you have decided to conduct the capability analysis, because you can't say no to him. Yeah, you can't oppose. Now, how will you calculate? Any idea? How will you calculate?
Better
Do you want
we
to
take
use yes
subgroup more.
That's what you have taken. You have taken data as revealed. You have taken 25 subgroup, and now the time is over. Now another 1 hour is available. You have to prepare the report and then submit to him. Now, how will you calculate? If I calculate capability analysis with this condition, what will be your CpCpk? Will be above 1.67 or below 1.67?
Below 1.
Below.
Below 1.6.
Yeah. chances are more for your CPK to go down. Isn't it?
Yes.
So, but you can't, your boss cannot submit that to the customer, because customer will be happy to sign the contract only if your CPK is more than 1.6. Now you understand the situation better, right? You
Yes.
want the order, you want to reject, you want to get your order rejected. You want
Get
the
the
order,
order.
right? So what we normally do?
We minimize outside the boundary. You have to cut the outside the boundary values.
Very good
Only
point.
within the limited value we have to show the customer.
You will only start considering the right data points, and all the out of control data points you will try to exclude. Am I right?
Yes.
That means all the red color points will now be removed. Your
Yes.
graph will,
Only
your
within
graph
the
will,
range.
yeah, your graph will look like something like similar to the R chart. Your X bar also will look like a R chart. And now excluding these points, your CpCpK will be much better.
Much better.
This is how we normally do. Am I correct?
Yes.
But are we giving justice
No.
to,
No.
yeah. So we have
As-
done something. We have done something to manage the situation. But the reality also we understood, right? But something we have to work in that fashion. We can't avoid, because organization requirement, because with some hope that the process will be better within a week or so, you can give that report to your customer. So you know the limitation of your report. Am I correct?
Yes.
At least you mention some condition, subject to the condition. CPK is 1.83, etc., etc. Subject to the condition. What is the condition? No outliers.
No.
Subject to the condition, because we only know there are a lot of outliers. Some language which your boss or other person do not understand, you can add those conditions in the bottom. Terms and conditions apply. When buying a credit card or loan, they put one
Yeah.
star and then they'll say terms and condition apply. You also put terms and condition apply. If they ask, you tell, sir, this is based on the study we have conducted at our factory.
Yes.
The
Yes.
plus
Star
and
one star.
minus of, yeah, the plus and minus of your terms and condition. Know your limitation and then speak. That's good. That's better always, isn't it?
Sir,
Yes.
but sometimes customer asks all the terms and conditions they give within 3 months. I will want this much of CpCpK and all this thing. Then
Very
what we
good.
can do?
That
Because
means the
he
customer is
demands
intelligent.
now. Yes,
That
that's
customer is
why
intelligent. You will be in trouble.
first offer it's okay. In next time, what we can do if it is not controlled? That is a problem.
That's what. If it is not in control, you have to correct it immediately. That's why the customer is asking you 3 months data. And
Yes,
even
sir.
after you give the report, he may come again for a surprise visit.
Yes, yes. Yes, definitely they will do.
Double sampling.
Yes. They
You-
are cross verifying.
Because he knows the subject. That's why he is asking in that manner. 3 months data. Even if you give the report, he may again, come for a additional visit. After you submit the report, they'll come for an audit.
Yes, yes, correct.
These are all the ways of understanding the fact.
Okay.
That's again a kind of sampling technique.
Yes.
All right. So now I want you to do the analysis yourself. So one of you can share the Excel file first, and parallelly your Minitab should be ready. So I'll make you conduct the capability analysis yourself so that all others can also do it. Who is ready now? The Sigma
Yes, sir.
level, we have another 10 minutes to do this. And then we'll be moving on to other topic.
Yeah.
One of you can share.
I can share the
Yes.
screen.
Yeah, please.
Yes, so you can see my screen.
Yeah, please go to coating thickness.
Coating thickness. I think it is on the right hand side.
Sir, I have one doubt.
Yes.
In examination, we can use this Excel and Minitab also, correct? Same.
Yeah, use anything that you want to use. It's an open book exam.
Okay, okay. That's all.
Only
And
thing
then-
is you should not make a call to RK or myself or other faculty. Yeah. All else you can do. Yeah.
Should not ask
Yeah.
answer directly.
Yeah. Okay. Please copy the file. See, the calculations also are shown manually.
Yeah.
Go down, all of you. See, there are many things I have shown the workings in the Excel file, which you all can, try to understand. It's a self-explanatory. You click that 49.88. One of you can, is that Vineet, right? Vineet, yeah.
Yeah.
Yes.
Average. Yeah.
Average.
49.
Average.
No, not this 49, left side 49.
Okay.
Yes.
This is nothing but overall standard deviation.
Yes.
Then what is this 49 right side? Right side, you come, go to the top and see first of all, go to the top. Yeah.
So it is a data.
Actually,
and this is
same
Same
only.
data, same
Same
data.
data actually.
Same
And now
data.
column G talks about subgroup average. Can you see that?
yes.
Yes.
Column
3
H,
divided by 2.
column H talks about subgroup range. Now come down, subgroup average, you come down along subgroup average, come down.
Bottom.
Yeah. Now what is the grand average? How much is the grand average?
49.88.
49.88.
Look at your initial average of
Same.
all the data.
Same,
If I
same.
consider the population as, all the 75. Now average of subgroup average gives me an accurate estimate of my population average. Can you see that? Average
Yes.
of the average. That is why I have suggested to work with the sampling distribution. Your estimation can be much, much better. Am I right or not?
Yes.
See, you can always know, you go up, go to the sample average, go to the sample average. Imagine you pick up the first subgroup average.
Yes.
How much it
0.2.
is? 50.28, right?
Yeah.
Yes.
This is called the sample average.
Okay.
But in the bottom, there is one average of the sample
Average
average.
of sample average.
That is, the sampling average.
Sampling average.
The advantage of working with the sampling distribution is your estimate is very, very close to the reality. That is why, and moreover, if you plot all these averages, the normality will be much better instead of plotting all the 75 data point. That is called the central.
Sample average.
This is called the central limit theorem. Instead of plotting all the sample points, you plot only sample averages. The normality will be very smooth because average will eliminate the error in your data, isn't it?
Yes.
All the inaccuracy will go out. As a result, the normality will be smooth. All right. Anyway, all these things you can, you need to know certain things you need to learn on your own. So now the calculations are here. So please copy column 1 and column 2. The Excel calculation is simple, self-explanatory. All of you can do it yourself. Right? To practice once, that is also important. Now copy this data, go to Minitab.
Minitab.
Minitab. Minitab, you have to open Minitab. You have Minitab?
No,
Yes.
no. In my laptop, no. Maybe someone can share. Sorry.
So I can open.
The opportunity goes to other participant. Yeah.
Yeah, I will open.
I have all the sharing. Stop sharing. Yeah.
Now you have to copy the data from Excel and then paste it in a Minitab file. Who is doing now? Sivaraj.
I am open.
Yes.
Yeah, okay. Saravanan is doing. Okay, you are open.
So I have to open both Excel and
Yes,
Minitab.
yes.
So I have to copy column 1 and 2.
Yeah, column 1 and 2 copy. And then you can share the screen and paste it in Minitab.
Okay.
Sarvani, you are sharing the screen?
Yes. Okay.
Yeah. You can type the name. See, you have to paste it from the first row. Now you have pasted from the second row.
Okay.
Or you can first row, you can delete otherwise. No, you have to delete 77 also.
Yes.
Now you paste. For C2, you give the heading, thickness. Thickness. C3 is subgroup. I mean, C3 is subgroup or role.
Huh?
C3, role. ROL,
Huh?
role.
Huh?
Role. So now, first of all, before conducting the capability analysis, what should we do?
You
should check whether the process
subgroup
is capable.
No, you should check whether the process is under control or not.
under control or not.
Because now that we understood, statistical control is important for capability analysis. So how can we check whether the process is under control or not?
Control chart.
Control chart. So what is the control chart I should use now?
5.
Data type is
Expert.
data type is continuous. Variable data. And subgroup size is
75. 70.
Subgroup size is not 70.
Subgroup
No,
3.
three.
Subgroup size is 3. Whenever subgroup size is 8 and below, you should go for X bar R chart.
Okay.
Data requirement is data type continuous, subgroup size 8 and below. So go to stat, control chart, variable chart for subgroup, X bar R, X bar R.
Yes.
All observation in one column. So click in the next box, white box, select thickness, subgroup size
3.
Subgroup size 3. Control X bar R option. Only
Control?
one X bar R option.
Yes.
Only one test is enough. Go to test. Test.
Test. Fourth one.
Don't select only the first one. Okay. One more. Okay.
Too few items.
So not selected the items like C2 and C3.
Yes. Thickness is
Wait.
not.
Wait.
Have to select.
Okay.
I'll go.
Oh,
expert.
C2 you have not selected. No.
Yes.
Close this.
Yes.
C2 is
Didn't select the C2 and C3 in the.
No, click in the box. Click in the white area. Yeah. Now you select.
double.
Click select. Give OK now. Process is
Yes.
Not
Export.
out of control. Don't jump. You're only studying the statistical control. You're not studying capability analysis, right? So don't talk about capability. Talk only about control. Process is statistically out of control. But your boss needs the capability analysis report. Now there are two options. You can do the capability analysis as it is, so that you get the as it is estimate of the capability.
Okay.
All right.
Yes.
So let us do, or otherwise what we normally do is we remove all the out of control points carefully. Out of control points are indicated in the report. Can you see that in the session window? Go to session window. Yeah, all the points. Exactly. All those points will be removed, and then your capability will look very attractive to your customer. Now let us do the capability. Yes, sir?
Yes, sir.
Yeah. Now let us go to the capability analysis. Sir, go to stat. Leave it. Go to stat. Stat.
Yes.
There is quality tools.
Yes.
Capability analysis. Normal. Single column thickness. Subgroup size. 3. When you say capability analysis, Minita will start asking specification limit.
No, wrong. It's 3.
Subgroup size
Oh,
is 3.
sorry. Sorry.
Subgroup size is 3. Then lower spec. You give lower spec. Also give upper spec. We know lower spec, upper spec, right?
Yes.
So lower spec is 47. Upper spec 53.
53.
Lower spec, upper spec. I think you can give okay.
So I can give this boundary with a tick mark. Tick mark is required for boundary.
Not required. You give okay.
Yes.
Okay. Now you got the values.
Yes.
Look at your CpCpK. Look at your PpPpk. You should know the plus and minus of this report before using it. Otherwise, you will go wrong very blindly. Am I correct?
Yes.
First of all, the study itself is not wrong. Am I right or not?
Correct.
The study should have been avoided, first of all. Isn't it? Because the process is out of control. As it is conditioned, it is giving this much value, CpCpk, etc. Right? But capability wise is okay. See why this, how this process is capable with a lot of out of control points. Can somebody answer this question? At least in the short term, the process is capable. Very good, isn't it? 2.46. 2.46 means more than 6 sigma. Am I correct
Yes.
or not?
Yes, greater than 1.66.
How it is possible? So many out of control points, but still capability is very high.
Groups which are in control.
How the process is so much capable with a lot of out of control points? Who can answer this question? Chocolate question.
That mean is very closer to sample mean is very close, right?
But okay.
There are many
49
points which are in control.
Variations are less.
For some subgroup, the variation is not there. So
Right.
From
Now, what is the pass mark for our exam?
60.
60.
60.
Do you think all of us will pass the exam?
Yes.
If you are teaching
Probably.
it,
We are capable.
yes.
We are just capable. Okay, we all will pass. With all the efforts, we all will pass. If I tighten this requirement, 80 is the pass mark, 80%. Now what will happen? Now situation becomes
Many
very critical.
defects. Many defects.
Right.
If I say the pass, if I say out of control, if I say the pass mark is only 40, now no doubt everybody is pass.
Within control.
So
Within control.
capability and control are different. Control means if all of you attend all our classes the way we are suggesting, all of you will score marks close to each other. That should happen. That is the reflection of the control. All right.
Yes.
All of you should score close to each other. If all of you score close to each other, all of you will be seen inside the control limit. Right? All of your marks will be seen inside the control limit. Normally, specification limits will not be there in a control chart. Am I right?
So voice,
Control chart
yes, sir.
will not have.
Voice breaking.
So control chart is only, control chart is, voice breaking.
Yes, sir.
Yeah.
Voice breaking.
Light, connection unstable. It should be all right now. Is it
Yes,
okay
sir.
now?
Yeah, okay.
Yes, sir.
Yeah. So control chart will tell you whether your process is under statistical control or not. That is what we have seen. According to our control chart, process is out of control.
Out of control.
But pass mark is only 40. So finally result is capable.
Good. Good.
Can you see a similar scenario here? Can you see scenario here, isn't it? CpCpk
Yes.
healthier with so many out of control point. What is the reason? Customer is so lenient. Customer tolerance is wider enough to accommodate all your out of control points. Am I right?
Yes.
Yeah.
Know all of this and then talk. But even with this much wider tolerance, your long-term capability is very weak. That also you can
Very-
see that.
Yes, less.
That
Yes.
also you can see that.
1.15, 1.9.
All right. So this is what you all need to understand while conducting capability analysis. Now you design your capability analysis in the best manner. If you want to design your capability analysis in the best possible manner, you will ensure your process is under statistical control. Am I right? That is the first condition you will check. Yes or no?
Yes.
Correct.
Then you will collect enough amount of data. You will collect enough amount of data spread over enough period of time. The enough has to be filled up by you. The enough has to be filled up by you. Let us say you maintain a inventory of 10 days. How many days inventory? 10
10
days.
days.
Now in this, and your company is running 3 shifts a day. Now tell me, how will you create the data collection plan?
30.
30 means 30 samples, huh?
30 samples. 1
Okay,
into 3.
30 samples. So how do you collect the 30 samples all at a time?
No.
In three different shifts.
3 shift.
Hourly
Okay,
breaks.
10 at a
Three
time. 10 at a time.
Yes.
10 at a time. Subgroup size is 10.
Okay.
When
Then
subgroup size
per
is
day
10,
30 samples.
per day 30 sample, and you said
Yes.
totally you will take only 30 samples, right?
Yes.
Per day.
Okay. But you missed including one important information. I told you your inventory is 10 days. Inventory
Oh.
is 10 days.
Per day
Then
30 samples into
per
10
day
days,
30
so
samples into
300.
10 days, 300.
Then also you are missing out on important thing.
Shift,
Well,
Sample size.
3 shifts. So
see,
3 shifts.
variation.
Minimum.
Yeah, I'll tell you. Now, what are we trying to do? We are trying to find out the source of the variation, right?
Yes.
Source or shift can act as a source of variation. That is called shift to shift variation.
Yes.
Only to predict the shift to shift variation, you collected data from every sample.
Okay.
Variation can be due to the incoming material quality also. Am I right?
Yeah.
Yes.
If you want to predict that, you can't, you can't conduct the study in 10 days. Because the first lot has come and you are using the same lot for 10 days, isn't it?
Okay.
Now, second lot quality can be different from first lot. Possible or not?
yes.
Yes.
If you want to understand that, you must stretch your study for more than 10 days. Then only it is possible.
Okay.
Do you get my point?
Yes. Yes.
The incoming
Then,
material, if there is a difference in the incoming material, if you want to understand, then definitely no, you must conduct the study for more than 10 days. 20 days means then you will have 2 different lots. Is it the second lot different from first lot? You get an idea.
okay.
If possible, you can stretch it for 30 days. So that's what I told you. Always the scenario has to be better understood, so that you can come out with a proper data collection plan and then do it. But if there are a lot of limitation, know your limitation and then still proceed. No problem. If you want to do the capability study within a day, within a shift, that is also possible. Within a shift, that is also possible. But accordingly, you try to use the best tool. Try to use the best tool. Now, all of you, do you know what is standard error?
Standard error.
Standard error.
Yeah.
Standard error. Standard error of mean. What do you know? What is standard error of mean? X double bar
Averages
is
of
Yes,
averages of standard
variance.
deviation
Averages of
Where?
within the subgroup.
X double bar means average of the averages. I know that.
Averages.
You also
Yes.
also know that. But my question is not about that. My question is about what is standard error of averages or standard error of mean.
Standard error of means
The
Standard
more
standard deviation
accuracy.
of sample population.
No. What is sample population? There is sample, there is population. Then what is sample population? Sample is there. We know the meaning of sample. We know the meaning of
Yes.
population, isn't it?
Yes, wider.
So sample from population, I think maybe you're trying to say sample from population. I asked you a simple question. What is standard error of mean?
There is nothing but the ratio of standard deviation to the variance.
Variance.
Still not clear. Not correct also.
Standard deviation by root of n.
This I agree. Who said standard deviation by
Satyanarayan.
root of n? Very good. I think we all must clap for Satyanarayan. Let us clap.
Okay.
Louder. Sound earlier. Yes. Because only one person could remember the lesson. Standard deviation by root of n.
Root of
But
n.
what is the meaning of it? Formula is correct. Very good. What is the meaning of it? Standard. Yes, sir. Go ahead.
Standard, it's a ratio between standard deviation and the root of number of samples.
You are correct. Standard deviation divided by root of n. Where what is n?
Number of
The number of samples.
Number of samples.
Number of samples in your subgroup. Standard error is nothing but standard deviation of the subgroup average.
Sir, can I come?
Yes, sir. You come.
Please note, tell me, suppose I have scored 80 marks. I have scored 80 marks. And you are asking my mark to Gopal Shivakumar. Gopal Shivakumar tells my mark is 40 because he doesn't like me. So he says mark is 40. Now, is there a deviation? Yes or no?
Yes.
Yes, yes.
Yeah.
Very good. And is this deviation an error or not?
Yes.
Yes or no?
Error.
Yes.
So this deviation is an error. The deviation error are same. Yes or no?
Yeah.
So
Yes.
error or deviation both are same. Yes or no?
Yes.
Right?
Yes.
Therefore, there is one standard deviation and then there is one standard error. Standard deviation is a standard error. Yes or no? It's an error.
Okay.
Standard deviation is an error. Understood?
Yes.
And then he coins another name called standard error. So that should also be a deviation. Yes or no?
Yes.
Yes.
So you are calculating deviation for individual values and then you call this as a standard deviation. Yes or no?
Yes.
You call that is population. Population, you take all the values individually and find out the variance, take the square root, and that is called standard deviation. Now, it is not possible for me to get that standard deviation. Is it possible for me to get that standard deviation by collecting all the 1 million values in the population? Yes or no? Is it difficult or easy?
No, it's complicated.
Difficult.
It is difficult. It's not possible. So what is the easy method? I take a
Take a
group,
sample.
like I want to find out the average speed of an auto driver in Chennai. So I can't find out the average speed of an auto driver because millions of auto drivers are there. So I take from one area, another area, 5 auto people, another area, auto people. So I collect the average speed of these groups. Yes or no? This I have got the values. Instead of 1 million data, I have got about 100 data because I have taken 100 samples. 100 sample values I have got, 100 mean values I have got. Yes or no?
Yes.
Now I can calculate the standard deviation for this data. Yes or no?
Yeah.
Yes.
And this standard deviation, I have to give a different name because this standard deviation will definitely be not exactly equal to the original standard deviation. Original standard deviation, I call it as sigma. This is a standard deviation. I am getting it because I can't calculate standard deviation of the population. Okay. So this standard deviation, I have to name it. So what name you can name it? Tell me, standard deviation or standard error?
Standard error.
Standard error.
That's all. Thank you very much.
Okay, sir.
So
Thank you.
standard error is calculated using using how many samples?
Standard error minimum.
Standard error is calculated using how many samples in the examples given by RK? Auto. How many
10.
samples?
5.
10,
5.
10.
Each area 5.
Each area 5. Okay, RK sir, you mentioned each area 5.
No. Each area
Okay,
I'm
but he
taking
assuming.
5
Okay,
auto
very
as a
good.
group. That is called subgroup.
Okay, anyway, I like the answer. Each area 5 auto, right? So subgroup size is defined. Now, how many area RK collected data?
10. 10.
He said
20
100
areas.
total 20 areas.
Okay.
So 20 areas, 5 auto each, so 100 data. Now he is asking you to calculate standard error. 20 areas, each area you will have an average, right?
Yes, 5.
Yeah.
So 20 average you have. These are called subgroup average.
Yes.
Now the subgroup average will have a deviation from each other.
Yes.
Am I right? That is
Yes.
known as standard error.
Okay.
Am I right?
Yes.
The standard deviation calculated using the subgroup averages is known as standard error of mean.
Error mean.
Very clear?
Yes.
Suppose RK cannot go to 20 different places. I think he can't walk to that much distance, isn't it? So he decided to go to only one place. He can still manage to get the
100
information.
sample. 100 sample.
Maybe he may take 100 samples, possible. Or he may finally come up with taking some 20 samples and come back. Because he can't go to 20 different places, he visited only one place. Probably he will take more sample now. Let us say he has taken 15 sample. Let us take he has taken 15 sample.
15 sample.
Now how many data point you have?
15.
15.
75.
15.
Yes.
Now you have 15 data point. Will you be able to find out the standard error now also?
But it's not accurate.
Not accurate. You know the limitation. Very good. Because you know the subject, you know the limitation. But still, that is the best he can do because he can walk only to one spot. If he walks to all the spot, what happened? He cannot come back.
Yes.
That will be, much difficult scenario than, the poor estimation. Since he can't walk to all 20 places, he decided to walk to only one place, probably take 15 samples there. Do you understand?
Yes.
This is how you all will also work in your workplace also. Am I right? If that is not possible, you have an alternate. So, only one subgroup of 15 data inside can also be used to calculate standard error. Again, the formula is standard deviation divided by square root of n. Again, what is the formula? Standard deviation divided by square root of n. In this case, standard deviation is standard deviation of the 15 data points. Standard deviation is
15.
Standard deviation of the 15 data points. N is 15.
15.
But you know which is better? Going to 20 different places is better.
More subgroup
So
is
that
better.
you can cover up the entire Chennai. Population is covered properly. Data collection plan is perfect. Sampling technique is perfect. Too many subgroups from the city center, near railway station, central railway station, Coimbatore bus stand.
Huh?
Because those are the places autos are flying more in number, isn't it?
Yes.
Yes or no?
Yes.
Central areas will always have a higher traffic. That is what we are seeing in the normal distribution. We see a peak in the center. What I am trying to speak here is, I want you to understand different standard deviation. One is standard deviation of the population. Another one is standard deviation of the sample. Another one is standard deviation of the sample averages. For population, it is known as population standard deviation. For sample, it is known as sample standard deviation. But for standard deviation of the sample average, that is known as
Standard
Mean
error.
error.
Very good. Very good. You are now a black belt. The advantage of understanding this is you can do more with less. You can do more with less.
Less.
You can predict well even with less sample. What was RK's technique the last day? He is not able to walk for too many places, isn't it?
Yes.
So he decided to go to one place
Particular place.
and took as much possible readings as possible. Yes or no?
Yes.
Normally his subgroup size is only 5. You remember our discussion. He said
Yes.
he'll take only 5 readings from one place and come back. But now he visited only one place. But how many readings he took?
15.
15 reading. You can even advise him to take 20 reading. You can even advise him to take 25 reading. And the industry practice is maximum 30 reading. After taking 30 reading, you calculate standard deviation and divide it by root of n.
Root of n.
So you get an estimate of standard error of the mean. What you can get by visiting 20 places, you got it just by visiting one place. Can you see that? All of you, do you understand what I'm speaking?
Yes.
Yes, yes.
By visiting 20 places, you are trying to get standard error of the mean. Now there is an alternate method. Why alternate method comes into picture? Because you have a knee pain. You can't walk. So what you did, you visited only one place, but you are putting more
15.
effort in the same place. Whenever you also have a problem collecting data over a month, you can do that in one day itself. Do you understand?
Yes.
One day, but collect as much data as possible. And instead of using the standard deviation, use standard error. Do you understand? Instead of using standard deviation, use standard error. But still, you know your limitation. Your limitation is you can't study over a month time. You had the limitation, so you collected the entire data in one day itself, but you purposely kept your subgroup size close to 30. All of you, do you know? Sample size 30 doesn't mean the total number of data is 30. No. Subgroup size has to be sufficient. When subgroup size is sufficient, the subgroup average will start following normality. If it starts following normality, all your predictions will be better because all our discussion is based on normal distribution. Hope it is clear to all of you.
Yes.
Hereafter, no more question about sampling technique, sample size, all of this, right? But specific situation, the more specific the situation, more better will be the answer from our side, right? More generic is the question, it is highly difficult to answer. Most of the time we struggle to answer your question because you keep your question very, very generic, right? So that's the point. So now this completes the process performance indices. Now I would like to, okay, already Saravanan is sharing, no? So
Yes,
Saravanan, you can go to file, Let us talk few things about control chart also. Oh, wait, here itself. So here itself, just a second, you come out. Now already he has some data. What is the data? X bar coating thickness data. He plotted the control chart, assuming subgroup size as
3.
3. If I change the subgroup size to 5, then also the control chart will be X bar R chart only. Am I right?
Yes.
Yeah.
If I change the subgroup size to 10, then I think 10 it is, yeah.
More than 8.
Yeah, more than 8, it will be X bar S chart. Since the total number of data point is 75, 75 divided by 10 is not a full number. So let me assume subgroup size is 15. Subgroup size is 15. So I have 5 subgroup. When subgroup size is 15, what is the control chart you will use now? X bar
X bar
R chart.
X bar S chart. R chart is over. Up
Yes.
to a subgroup size of 8 R chart. After 8, it is S chart. Saravanan, can you
Yes,
plot X
yes.
bar S chart now?
Yes, sir. I can close this one.
No, not required. You can say parallelly do. Go to you do it. No. No, cancel. Let all of them be there. Cancel.
Cancel.
Yeah. Start.
Yes.
Oh, let it be no problem.
Control chart.
You go to start. Control chart.
X for S.
Variable.
X bar S.
X for S.
Yes.
Variable chart.
Thickness.
10. Subgroup size 10.
Group
Select.
X bar
Subgroup.
S. You come through country for subgroup. Yeah.
Yes,
15.
X bar 15. Then
1,
X
5.
bar S. X bar S option.
Yeah, option. Whatever condition, as many conditions you
Yes.
want to put, you can put.
Yes, 1 point is.
Only one condition.
Yes.
See, extra condition, if you want to put, you should know
Yeah.
whether putting that condition will make sense
K point.
at that point of time, right?
Okay. No need to put
So only one.
Yes. Okay.
Put okay.
Oh,
Okay, and one more okay.
yes. All are inside.
All are inside. Now all of you, the control chart now looks under control, right?
Under control. Yes.
But now you all know that there are certain assumptions here and limitations here. What is the assumption? What is the limitation here with our control chart?
Subgroup
Assumption.
15.
Subgroup size is 15, but actually the real data is subgroup size is 3 only.
3 only, yes.
Yes.
We just assumed as 15 and then we are plotting this. So that is the big limitation, isn't it?
Yeah.
And that's why, the process now has become under control. So always anything you do, you should know the limitations in your study.
Sir,
Right?
one thing. Sir, one thing. Actually, in the Excel, we are taking the sample only 3, but the same sample we mention here for 15 subgroup.
First of all, that is illogical.
That means, yeah. Okay.
That is illogical.
Okay.
But we are doing it for some purpose. So that's what I am telling you. Always the study, the situation has to be understood so that, you can use the tools accordingly. Otherwise, even though you have the right tool in your hand, but still it can point a wrong direction.
So, but in daily experience, I'm asking, without knowing this Six Sigma, we can explain like this illegally, but if known person, they can capture. Correct?
Correct. And now, suppose if the subgroup size is 1,
okay.
Subgroup size is, that means one sample at a time you are taking. Maybe a destructive testing. Now you will go for IMR chart.
IMR
Now
chart.
you will go for IMR chart. Correct?
Yes.
So go to stat, control chart, variable chart for subgroup, come to IMR. Wait, next one, not that one. Come back. And variable chart for individual. IMR. Now thickness. Okay. This is for IMR chart.
IMR chart.
The variation is the difference in the subgroup size.
Okay.
The difference in the subgroup size.
Subgroup.
The subgroup size will be 1 when the when that study is destructive or something. And
Destructive.
similarly, control chart test, in all the cases, you have applied only one condition, isn't it? What is the
Yes.
condition?
That is
Outside control limit
outside
is
control limit. 50.
special cause.
Yes.
Again,
50.
the number of condition depends on your understanding on the process. If your children are at the age of less than 5, how many conditions you will put? More
Minimum
conditions or
condition.
less condition?
Minimum condition.
Minimum condition.
Minimum.
Now they are in an age band of 5 to 10. They've come, close to 10, under 10. Now you will add conditions, right?
Yeah.
Double.
Then they go to the band of 10 to 15.
Triple.
Triple.
Yes.
And then they go to the band of 15 to 20.
Yes. Again more.
More. Then 20 to 25, they get married in this band.
No condition.
No, it will
condition.
reduce.
You will, yeah. Sometimes putting more conditions will make sense. Sometimes, it may not make sense. So, initial stages, if there are too many out of control points, you focus on with a few conditions, right? The first condition. And then
Yes.
if you are able to achieve that, you put more condition. You put more condition, and thereby you are trying to make your process more and more consistent. If it is more and more consistent, it becomes more and more predictable. More and more consistent means it becomes more and more predictable.
Predictable.
And more improvement is possible.
Yes.
And more improvement becomes sustainable. Do you understand? We are trying to achieve improvement which are sustainable ultimately, isn't it? Otherwise, you are not required. Anybody X and Y can give improvement, isn't it?
Yes.
But what is your specialty? You will bring sustainable improvement.
The growth should be linear.
Sustainable improvement. So that is why, we want the process to be under control. Is it clear to you?
Yes, sir.
Very good. I think we can stop here. And now we understood certain things. Difference between CpCpK and PpPpk. And then control chart also we have understood. Control chart for variable data.
Okay.
Depending on server price, IMR, X bar R, and then X bar S. In X bar R chart, what is the variation R chart is monitoring? What is the variation R chart is monitoring? Is that R chart is monitoring overall variation? Within variation? Or
Range.
between variation?
Within.
Within. R chart is within.
Within.
X bar chart is?
X bar chart is boundary.
Between.
Between.
R chart
boundary.
is within, X bar chart is between. Always we should have a clarity of what is within variation and what is between variation. If you master this, you are a master of all the tools. Repeatability is monitoring within variation. Reproducibility is monitoring between variation. The variation within appraiser is known as repeatability error. The variation between appraiser is known as reproducibility error. The overall variation is the overall error. Am I right?
So repeat once again, sir. Within capability, R chart error. R chart.
No.
And,
R chart is a control chart that monitors variation within or monitors within variation. It can be within a batch, it can be within a shift, or it can be within a machine, or it can be within an operator, within a day, within a week. Whenever you can use within, the word within. Because your data collection is based on that. If you collect data shift wise, then the meaning is R chart will monitor within shift variation.
Okay.
X bar chart will monitor between shift variation.
Okay.
Within supplier, between supplier. Possible or not?
Yes.
If you collect all the data from the same supplier and then monitor it, that is within supplier variation.
Yes.
Then
Different
R
supplier
chart will be helpful. Whenever you want to
Yes.
monitor within variation, use R chart. Whenever you want to monitor between variation, you use X bar chart.
X bar chart.
But many times you want to monitor both. That is why we go for X bar R chart simultaneously. First chart to plot is R chart.
Okay.
If R chart is under control, then only X bar chart must be monitored.
Okay.
That means you can compare two suppliers if both the suppliers are first of all consistent. Consistency is the key starting point. Consistency is the starting point.
Key point.
Imagine you have 10 suppliers. If you want to compare the 10 suppliers, all 10 suppliers should follow a particular procedure, isn't it? Then only you can compare.
Yes.
If each one is following different procedure, what is the point of comparing?
No meaning.
Since they follow different procedure, there will be difference. Difference should be avoided only when all of them follow the same procedure. If all of them follow the same procedure, then there will be consistency in what they are doing. The variances, you are trying to make the variances equal. That is why while ANOVA, the condition, variances are equal. Isn't it?
Yes.
So once variances are equal, now you can monitor the variation between the suppliers in a X bar chart. Supplier 1 average, supplier 2 average, supplier 3 average. You expect all the average to be equal. You expect all the average to be under control. Hope all of you understand what is the meaning of variation within and variation between. Within variation and between variation. You should be able to apply it in real-time scenario. Helpful?
Okay. Yes.
Yeah.